Okay, so hello everyone. My name is Peter. Thank you. I'm the creator of the Spock framework, and today I'm going to give you a small whirlwind tour about Spock, the different areas in which you can use Spock to test your Java code, Groovy code, Spring applications, and even your web applications. I only have 5 or 6 slides today, and everything else will be live demos. If you have any questions, please let's discuss them right away. So for those of you who haven't heard about Spock before, Spock is a developer testing framework, so it's targeted at people who like to write code. It has been around for a while already, since 2008. It's best suited for testing Java and Groovy applications. So your application could be written in pure Java, works just fine, pure Groovy, or a mixture of the two. It's based on Groovy, which means that the test itself, a Spock test, is always written in Groovy. But the code under test could be either Groovy or Java or a mixture thereof. Spock is fully compatible with JUnit, which is really important for the tooling story. So to each IDE, to an IDE, to a CI server or a build tool, a Spock test looks like, just like a JUnit test. So everything that knows how to run JUnit automatically can run Spock without even being aware of it. But we try hard to truly innovate in the space and give you something new and fresh that goes beyond what JUnit offers. Okay, so before I get started on the demos, for those of you who are already using Spock, a few very helpful links. There's the reference documentation. Maybe that's fairly recent. And that was a bad guess. I already have it opened here. So that's a new reference documentation, docs Spock framework.org. It's not yet complete, but it already covers 2 of the most involved topics of Spock, which is data-driven testing on one hand and interaction-based testing, that's stubbing and mocking on the other hand. So Spock has a mocking framework built in, and it's already documented in detail in the new reference documentation. So that's one good link to know if you need to look something up. And the other one, if you don't know Spock yet and just want to play around with it without installing anything, there is web console Spock framework.org, which is a fork of the Groovy web console, which lets you easily run a Spock specification in your browser. So I'm not sure if I should dare to run it here, but let's try. So this is a Spock specification. It's very similar to JUnit in that you have a class, which is your test class, and then it has a number of methods, which are your test methods. So structured similar to a JUnit test. Obviously, it's not Java, but Groovy. But if you're new to Groovy, you can write Groovy in such a way that it looks like Java. Actually, like 95% of valid Java syntax is also valid Groovy syntax. And there are a couple of small differences. So we see every class extends specification. We like to call our test specifications. That's also how we like to think of them. And this gives you some base API that you can use inside your test. Like, for example, to create the mock object, all of that. The core API you find on that base class. And then we have here in our specification class, we have only one test. And here you see the first slight departure from JUnit. You can write out a whole sentence. So you can name your tests really nicely. And you can write the sentence. So this is actually a method name. But you just write it as a string, and it will show up this way in all your reports, in your CI reports, JUnit reports, in your IDE even. And once you get used to that, you don't want to go back, because it's so nice to give each test a nice name as a full sentence without underscore or any other magic. So that's the first slight difference. And then this is a simple state-based test. So it just, in this case, we test this built-in Java method. Computes the maximum of 2 numbers, and okay, maximum of 1 and 2 is probably not 3, so we would expect this assertion to fail. And how this works in Spock is, in Spock you divide up a test method further into what we call blocks. And this expect colon is an expect block, and everything what comes after that is automatically treated as an assertion. So you don't need any assertion API, you don't even need an assert statement. Spock knows that everything that follows this expect, every Boolean expression, and you can line up as many as you want, is an assertion. Okay, so let's try to run this guy. I'm not sure this is live. So if this doesn't work, we'll run it in the IDE, which is probably a safer bet. So typically what you would see after a few seconds, it needs to spin up. It's running on App Engine. You would see the script output down there. but it's not looking very promising, so maybe let's switch to the IDE. Okay, so here comes my first example, a little bit more involved than the hello world. So this is for Java testing. So we have production code written in Java, and we want to do plain unit testing. It's a very boring class, an account class, and we can set an initial balance and get the balance and withdraw an amount. That's all we can do. And the only little thing of interest is here, if we try to withdraw more than what's in the account, then an exception is thrown. That's the only thing. So now let's try to test this Java class with Spock. So here we go. We have our specification, extends the class, and what we want to test is the withdraw thing. And here you again see how a method is split up in different blocks. There are a couple of such blocks, not just the expect, but also when and then. And the idea is as follows. In the given block, you prepare your object that you want to test. In the when block, you exercise it, whatever you want to test. In this case, we want to test the withdraw method. And in the then block, that's where you put your assertions. That's the basic anatomy of a state-based Spock test. So we initially have an account with a balance of 5, we withdraw 2, and we expect 3 to remain. And one thing that you already see here, since it's written in Groovy, a lot of the Java boilerplate just goes away. That's not Spock here at work, but that's Groovy. You know, you have literals for the big decimals. For example, you don't have semicolons. You can leave off the type on the left-hand side, and so on. So it becomes really, really nice and really readable. And this together with Spock's blocks that separates a test into semantic parts, it hopefully helps to make the test more readable. Okay, so let's try to run this guy. So to IntelliJ, this is just a JUnit test. And so we should be able to run it as a JUnit test, and you see it passes. We withdraw 2 and expect 3 to remain. Now the question is what happens when we make it fail, because that's why most other testing frameworks have an assertion API, right? So that they can give you good output in case the test is failing. So let's look what we get here. This is the output you get for free from Spock, the kind of output. So you just write a Boolean expression, and with Groovy, you can write really neat Boolean expressions. So you can easily write something, at least one element in this collection should have a length greater than 3 or something like that. So with Groovy, your Boolean expressions become much more expressive. And if it fails, you get, in the error message, you get the assertion here, and you get the value of each sub-expression. So you see the actual balance was 3, you expected it to be 4, and that's not equals false. So that's what you get for free. You also see really nice stack trace filtering. So stack trace is filtered down to a single line because that's the line that matters. You don't need to see the JUnit or Spock internals. And if you click that, it automatically jumps to the failing assertion as you would expect. Yes, there's another thing. Whenever you compare in Spock, compare two values in an assertion with an equals, it will give you an additional view on that. So for a number, I probably don't need much more than that. But imagine I compare two large bodies of text. So for every comparison of that kind, you get in IntelliJ and also in Eclipse, you get a diff dialog. And now imagine this is text. This would be really useful. And actually, I'm going to show it to you in a minute. OK, so for those of you who haven't seen Spock before, in a nutshell, that's the easiest Spock test. Testing pure Java code is specifically designed so that all features work also when testing pure Java code bases. And that's the basic structure of a state-based test. So we set up our object on a test, we exercise it, and then we check its state. Similar as to how you would do it in JUnit. OK, everyone with me so far? OK. So designed to test Java code, you already saw some of the diagnostics, but you will see more. A mocking framework is already built in. You can use it together with a mocking framework like Mockito, but many people prefer to use the built-in one, and I'll show you that in a minute. What also do we have? We have some support for asynchronous testing. So if you have an integration test that calls your code under test and that calls you back in a different thread, you need to somehow synchronize so that your test doesn't end prematurely. And we have some support for that, and I'll give you an example for that. We have a number of extensions. Spock is very extensible. We ship with a couple of extensions out of the box, and there are also third-party extensions. So one you'll see today is the Spring extension to integration test your Spring applications. We also support the Choose dependency injection container, Tapestry dependency injection and web framework, Unitils, which is a tool that helps you write integration tests with JUnit. Simply works with Spock. Also JUnit rules, for those of you who happen to know JUnit rules, which is the new preferred way to write reusable logic for your JUnit tests. JUnit rules just work with Spock without you having to do anything. So there are a number of extensions in Spock, and I'm going to show you some of these features right now. This looks like a freeze or not. Okay. So let me show you some of the diagnostics. Again, we're doing state-based tests. We're just comparing things. But we are comparing not only numbers now, but a little bit different, more interesting objects. So we might compare two collections in our assertion, or we might compare two potros, or we might compare two bodies of text, which is the kind of, what is the kind of output that you get from Spock. So let's compare two collections, right? So I need to make them not equal. Let's say this is our assertion, and now let's run the test. I think I've lost my keyboard somehow. So let's run it here. Okay. We need to make it fail first. Yeah, without a keyboard, it's difficult to make it fail. Yeah, that's what it is. I have lost my keyboard. Okay, keyboard has decided to come back. So let's try to run it once more. Yes, and it's failing, finally. So you get the usual output, but you see as the collections that you compare get more involved, you no longer immediately see how these two collections differ. And here is where this diff dialog comes in handy. So Spock knows how to render a collection. And in case of a set, it will order them alphabetically. So that gives you a nice way to compare. And you immediately see, oh, this entry is different. So one entry is different. So that's a nice way to figure out what's failing. It can also do that for potros. So it has a comparison strategy for potros built in. So let's change this around a little bit. And then I show you the diagnostics with keyboard. So again, it's failing, diff dialog. It prints out all the potro properties sorted. So you see address is different and age is different, and name is the same. And it has a couple of strategies how to render such expressions. Of course, you still need to apply a little bit of judgment on your own, because it could render, it makes a string rendering of each object. And so in theory, the strings could be the same, but the object's not equal. But it tries to do its best, and it helps to find the problem in general. So last one, what is that? It uses the Groovy equals operator, which in general is the Java equals, except in some cases it's a little bit smarter, but in general it's the same than the Java equals, yes. And again, you don't have to use an assertion API. It figures that out automatically for you. So here are the bodies of text. Even here, it already gives you some hints. It says two differences. So two characters are different here, and it would highlight them. But it's painful in the IDE. You simply do this, and you see immediately where the differences are. And you get the same thing in Eclipse. In Eclipse, you just have to know where to click because there is no click to see difference. You have to click on the very first line that has the exception name. If you click that line, you'll get the similar diff dialog in Eclipse. Okay, so that's some ways in which Spock tries to be smart. You do nothing, you just write the Boolean expression, a nice simple expression, and Spock gives you a nice diagnostics. Mm-hmm. So the comparison is always the, Groovy equals, which is more or less the same as a Java equals. What you see in the diff dialog is then just an interpretation, right? But it doesn't affect how it compares the objects. So it compares the objects. If you use equals equals here, it calls the Java equals method on the object on the left-hand side. So yeah, it doesn't mess with the semantics of Java objects or something. This diff dialog is then just on top of that. It tries to give you a nice visual way so that you can easily figure out what's wrong. Okay, we also have built-in way to test for exceptions. I'll skip that because many of you will already have seen it, but there is no try-catch block or anything. Here is our DSL for saying, I expect this exception to be thrown. So the class name equals thrown, and that's all you need to do. And then Gradle will make sure that the when block where you withdraw a negative amount really throws that exception. And then you can add further assertions, which is also handy. So you not only check that the exception has been thrown, but you can just add further assertions and check, for example, the state of the assertion object. So we have handy ways to test for exceptions, as you would expect. Now let's make it a little bit more interesting. And let's have a look at mocking. So who's used mocking with Spock before? Okay, a couple of people. So let's have a look. Let's start slow, but I have some more interesting samples as well. But for those of you, like 2/3 people haven't seen it, so I quickly go through the simple example. So in this case, we are testing a publisher class. And in this case, it's the class under test is also written in Groovy. In the previous example, the class under test was written in Java. Here it's written in Groovy. And it's the canonical example for mocking. So we have this publisher class. This is the class under test. It maintains a list of subscribers. That's the Groovy literal for a subscriber, for a list. And it has one method which allows you to send an event from the publisher to all subscribers. And it simply iterates over all the subscribers, calls the receive method on each subscriber. And if one subscriber screws up, it just swallows the exception. Should probably log it there, but the important point is the remaining subscribers will still receive the exception, even if one of them throws an exception. And then we have this subscriber interface. So this is the collaborator of our publisher, and this is the guy we want to mock. We want now to provide different test implementations of the subscriber, and then we want to check how the publisher deals with those subscribers. So this is our production code. And of course, typically that would go into a separate class. And now here's our specification. We extend the specification class as usual. And now we set up our object under test. So we create the publisher. And then we need to create two mock objects. And this is the mock method that comes from one of the base classes. So you can navigate there and you can see the Java doc. That's how you create a mock object in Spock. In Groovy, you don't have to write the .class. So in Java, you would write, I want a mock object of that type. But again, in Groovy, makes it more readable. You can leave off the .class. So we create one publisher, two subscribers to make it a little bit more interesting. And then this is the same as Groovy's had before. So where you can set up your test. You can use the JUnit add before annotation. Spock understands that. But the idiomatic way in Spock is to have a method that's called setup. And that will be called before every test. And what we do here is we just inject the two mock subscribers into the publisher. So that's fancy Groovy for list.add. Instead of list.add, if I want to be really fancy, I can use the left shift. But I could also have written subscribers.add sub1 and subscribers.add sub2. Okay, we are set up, and now we want to send an event from the publisher and check whether the subscribers receive it. And this is the basic way how you do mocking with Spock. So this tests that the publisher delivers events to all of its subscribers. So this is the real object. We send a message, we just pass a string, and these are the mocks. And this is how you specify mock expectations in Spock. They go into the then block, and you have to think of it as a DSL, not as literal code. The idea is you expect on the subscriber 1, you expect the receive method to be called exactly once, one times, and you expect an argument to be passed that is equal to event. So that's how you specify which calls you expect to happen on your mocks. And the same thing for a subscriber 2. Both of them should receive the event message that we sent up there. So this is the real guy, these are the mocks, and this is how simple it is to tell Spock what you expect to happen. Let's make it a little bit more interesting. Let's make one subscriber misbehave. So what we now want is that one subscriber throws an exception. And we want to make sure that the second subscriber nevertheless receives the message. So we need to give this guy some behavior. We need to make it throw an exception. How do we give a mock some behavior? And you do it this way. You say, I expect whenever on subscriber 1, the receive method is called with any argument. Any is always underscore in Groovy. I admit I was a little bit inspired by Scala. So whenever you're not interested in something, use the underscore, and it helps you not to over-specify your test. And especially mock testing, you shouldn't nail down everything. I expect this to be called with the number 3,500,000 and so on, so on. You should leave out everything that's not essential. Only the thing that's about the contract between your objects that you should specify. Otherwise, if you nail everything down, then every time you make a change in your implementation, not in your contract, then all your mock tests will break. So think hard about whether it's essential what's passed or not. Okay, so whenever this guy receives a message, it should behave in the following way. The behavior always goes after a right shift. And here, that's already a more complicated behavior. We pass a Groovy closure, like a Java Lambda. And in here, we can execute any code. So we don't need a special API like other mocking frameworks has and throw exception or something like that. We just pass a code block. And this code block will be run whenever the receive method on subscriber 1 is called with any argument. So we've made subscriber 1 throw an exception. And I don't have to declare it because it's Groovy and there are no checked exceptions. Okay, so let's test it. We send now, 2 events, 1 or 2. And let me see what we expect. We send 1 and 2. Do I get it? Oh, the subscriber 1, it always throws an exception, so we'll throw an exception twice. And nevertheless, we expect the subscriber 2 to receive the message. So the publisher is kind of fault tolerant. It will notify us even though this guy throws an exception.
Could you test that sub 1 didn't get any?
By default, Spock is lenient, so it doesn't test that. But you can always add 0 times anything. That means no other calls. And there's this running gag in Spock. You can say, you expect 0 calls on any mock object, any method, with any parameter list. And if you get that, please return the default value for the return type of that method. So that's the running gag. Oh yeah, it could be called any number of times. And that's valid, Spock, but I don't recommend to use it that way. So if you want to make a strict mock, then you say nothing else should happen. That's the canonical way to say nothing. Yep.
Where you set up the mock to throw the exception, if you had said event 2 specifically, would it have only thrown the exception when event 2 was called to the send?
Yes, exactly. I can say, yes, now it would only throw it on event 2. Maybe I should prove some of this. In case anyone doesn't believe me. Actually, not sure. I'm throwing an exception back to that class, a checked exception. Too many invocations. So which one are we? I have the 0 times. There's something else is happening. Because the method is also called on subscriber 1. So that's the kind of output you get. Too many invocations for this thing. There was 1 invocation of something else. And then it also told you which that was exactly. So receive with event 1 was called on subscriber 1. Then this guy would throw an exception, but nevertheless, the test failed because we said nothing else is supposed to happen. So you get pretty good diagnostics comparable to other mocking frameworks. And again, the stack trace is fairly small. It's filtered as good as we can. Okay, that was a little bit of mocking. Now, for those of you who are already using that, I want to step it up just one more level so that you at least get to learn something new today. Let's see what we have. So since the last Spock version, which has already been out for a while, we have some other mock objects, more specialized ones. We not only have mocks, but we have stubs and spies. Stubs are all about returning information. So with a stub, you don't care how often is it called or whether it's called at all. You don't care about that. You just want to return some information whenever it's called. So it's a weaker form of a mock object. But if that's all what you need, then by using a stub, you're telling the next guy reading this block, this test, you're telling him, hey, this mock object is just going to return canned answers, and I don't care if it's called and how often. So it's a form of communication, and also the defaults are a little bit more aggressive. So if on a regular mock a method is called that you don't explicitly tell Spock about, then it will always return 0, false, or null as a return value. So the default value. The stub is since the stub is all about returning, it's a little bit more aggressive. So it never tries to return empty. So it always tries to return empty and never null. So it will return empty string, it will return empty collection instead of null, which is usually a better fit. If you pass an arbitrary, if it needs to return an arbitrary object, it will automatically create another stub and return a stub rather than returning null. So it's more aggressive with its default in terms of what it returns, which can be useful. Then we have spies. That's a special case. They call through to a real object. So a spy sits between your class under test and the collaborator. Both are the real guys, and the spies just listens to what's going on between them, which method calls happen. And it can intervene. It can say, no, return the original return value or change that return value. So it's an advanced use case, also very popular in other mocking frameworks like Mockito. If you want to test the interaction between two real objects and just listen in on that, you can use a spy. And the spy here we expect on that guy the sing method to be called, and the spy can then decide what to do. He can return his own value, or he can call through to the real object and let that return a value. So if you have need for some advanced cases, then have a look into stubs and spies. But by default, it's best to only, if you have a clean code base and you use dependency injection, then usually stubs and mocks should be your weapon of choice. And spy is more about edge cases and about legacy code that you cannot touch. So use it with care. So we have stubs and spies. Also, by now for a stub, often case you want it to always return the same thing. And you can do that right when you initialize it. So instead of doing it down in the test, you can give it some behavior right here. So for example, if the sing method is called, I think the person has a sing if I remember correctly. Yes, the person can sing. So you can tell it if the sing is called, then return something. And that kind of makes it easier to understand, because everyone now kind of knows, okay, this stub will always have the same behavior. So it's again a nice method of communication. Actually, in IntelliJ 13, oh yeah, does it recognize it? In IntelliJ 13, this can be code completed, but apparently I'm using early access of IntelliJ 14, and apparently I have some work to do, because I'm teaching IntelliJ a little bit about the Spock DSL, so that it can refactor that automatically and that you can navigate it. I mean, you can navigate all of that, but even this sing method, it should find it. Okay, so this is some advanced mocking. I have a lot of things to show, so I have to be careful not to talk too much about one topic. So maybe are there any pressing questions? We have also support for Groovy mocks in the latest version. So if your code under test is written in Groovy, you're testing dynamic code, then you can do all sorts of funky stuff if you really want to now. So for example, here we have a Groovy mock for that person. And now in Groovy, we can call dynamic methods on that guy, right? Methods which are not declared in the class, but maybe there's some metaprogramming going on, like in Grails, and someone catches this method call, even though statically that method doesn't exist. And now you can mock dynamic method calls. So I'm mocking a method that doesn't really exist in the class in case someone calls it. That only works if your code under test is Groovy. And so there's a Groovy spy, a Groovy mock, and a Groovy stub. But you only need to use them if you want to mock like dynamic method calls, or even worse, you can mock constructor calls, you can mock static method calls, all the stuff you shouldn't do. But all of that only works if your code under test is written in the caller, is written in Groovy. So many people ask, oh yeah, I have this legacy Java app and I really, really need to mock the static methods, and now just with Spock and a Groovy mock I can do it. No, you cannot do it because the caller in this case has to be a Groovy class. Only then does it make sense to use the Groovy mock, Groovy spy, Groovy stub. And it goes even further, like you have a legacy code base, or for whatever reason, you create your spy in this case, but you can't inject it into the code under test. So here I say I just want to mock all the person objects that are used by my code under test. It creates it with new, I can't affect them, but I still want to mock them. And you can do that if your code base is written in Groovy. So you can here say all the person objects used by my production code, just mock them. Don't use the real ones, but check that on any of those person objects, a total of 2 calls happen there. So you can do lots of crazy stuff if you need to, but again, try to keep it simple and only use these advanced features if you really need to. Okay, any pressing questions for mocking? Otherwise, I want to move on because I have so much more to show. Yes?
Yeah, so if you set up a mock in the setup method, and you want to override it for a single test.
Yeah, so the question is about overriding. If you set up a test in the setup method, how can you override its behavior for a particular test? Is that the question? It's a little bit limited because I don't really like the pattern, but there's one way to do it. Everything you expect in a then block has precedence over what comes before. So you can put everything into a then block, both the stub assertions and the mock behavior. You can put everything in the then block, and if you put it there, it will have precedence over anything configured before that. That's currently the only way to do it. The other way would be not use a setup method, but create a helper method, that takes some arguments, and then call it every time at the top of each test method. That's a little bit more code, but gives you more flexibility. So these are the 2 ways to solve it. Okay, let's move on. I have more things to show, and especially higher level tests. So we've quickly talked about, without showing you all the details, that if you're testing Groovy application, you can do some advanced mocking. You also get everything that you get for testing Java code bases. There are also some more utilities for Groovy metaprogramming. So if you need to reset the Groovy metaprogramming between your tests to start from a fresh state, then there are some utilities for that. And also, perhaps you know that since Grails 2.3, Spock is the default testing framework for Grails. Of course, you can still write JUnit tests, for example, with Grails, but Spock is the default, and it integrates really, really well with Grails. I'm not going to talk more about this here, but if you're using Grails, then have a close look at the Grails Spock integration that ships out of the box with Grails by now, since version 2.3. Okay, so since we are at Spring 1, let's talk a little bit about testing Spring applications. The story is really easy. Who of you is familiar with the Spring test context framework for integration testing your Spring applications? Okay, good. So Spock simply fully supports the Spring test context framework. So Spock doesn't add any APIs, nothing, nada. You just use it exactly the same way you would write the Java JUnit test with the Spring test context framework. The only thing you need to do is you need to, in addition to Spock core, you need to put Spock Spring on your test class path. That's the only thing. And then you use the regular Spring test context framework APIs, the annotations like at context configuration. You can It will start up your application contexts. You can inject beans into your Spock test classes. Works exactly the same way as for JUnit, except that you can now write the tests in Spock. And it supports Spring Test Context Framework 2.5 until the very latest. So you should be covered there. So let's have a look. Last night I noticed that there was one tiny feature missing in our support for the Spring 4 Test Context Framework. So now you know how I spent my last night. I added that feature in. So here we have an example. We have a simple boot application, Spring Boot. And actually I took that from the Spring Boot samples. It's the simplest sample they have. So it's a Java class, our simple app. It has one main method that fires up the application, and all it does in its run method is it calls this Hello World service and asks it for a greeting and then prints that out. And that service gets injected here with add autowired, and the service is implemented over there. So that's the real example from the Spring Boot examples project. And here we inject the property value called name that's defined in this application properties, and that's what we're going to return. And of course, I had to make a change to that file compared to original one. I had to change the name to Spock. Sorry, Phil. Okay, and now what does the test look like? So this is our test. It's written in Spock, and basically it looks exactly like the JUnit one. So we extend specification. We use this annotation, Spring application configuration, that starts up your application context. And this is what we didn't support before, because this is an annotation which itself carries further annotations like a Spring stereotype. And so annotating your test with Spring application configuration is exactly the same as annotating it with this slightly more complex annotation. So you can have your own annotations that serve as shortcut for a number of other annotations, since I believe Spring 4.0. And until last night, we didn't support this particular one, so you would have to copy-paste this longer line. But as of today's snapshot, we do support that as well. So we can give that a try and just fire up our boot app. Again, to IntelliJ, it's just a JUnit test. So here we can see the logo. It prints hello Spock, and we just had two assertions. So we inject the application context here. Usually it would be better to inject a bean, not the whole application context, but we can do it if we need it, and then we check that our service bean is there, and the boot app itself is also there, another bean. So just put Spring on your application, on your test class path, and use the Spring Test Context Framework annotations and APIs, and it should just work. Okay, I don't want to spend a lot more time on that. So there are, of course, as with JUnit, you can also use the add resource annotation to inject, and there are a couple more things to that. But the Spring Test Context Framework has excellent documentation, and everything that you find there should just work with Spock. That's the philosophy. Okay, this was a little bit about testing your Spring and integration testing your Spring applications. Now let's move on a little bit. And let's talk a little bit about testing web applications. And I mean end-to-end testing. I mean firing up your web application and then scripting a browser to hit your web application and see how it reacts. And Spock is a really good partner in this crime, but you need something to drive your browser. You need something that controls the browser, something like Selenium, and that allows you to script your web application. And the tool of choice there for Spock is Jab. So who of you knows Jab or is already using it? Okay, quite a lot of people, good. So that's a Groovy library that sits on top of Selenium. Or WebDriver, the two projects I have used a while ago, and gives you a really, really nice and easy way to script your browser. So all the heavy lifting is done by Selenium under the hood. Selenium eventually, integrates with all the browsers, but it gives you a really high-level, nice API, and it covers some use cases that are especially useful for testing, which aren't covered by Selenium. So Selenium is the low-level, heavy lifter, like let's say the JDK, and then this is the convenience library that sits on top of it and makes driving your browser so much easier and so much groovier. And CHEP is test framework agnostic, so you can use it with JUnit or TestNG as long as your test is written in Groovy, but it works particularly well with Spock. There's a little partnership there going on, like with me being a committer on CHEP without ever having done anything meaningful, and Luke Daly, the creator of CHEP, being a committer in Spock and having done a lot of useful things. So that's a very fruitful cooperation. Okay, and I'm going to show you some examples without diving into the deep details, but to give you an idea what a Spock CHEP test looks like and feels like. And I'll also dare to show up our new reporting, which is still in the works, but some people have been waiting for. Okay, let's have a look at that. So first of all, now we need a real web application that we test, right? And so I have already one. I have a small Webpack app that I already fired up in the background, if I'm not mistaken. So this is our spectacular application that we are going to test. It has a few pages. It's all about logins. So here it has a login, and I can try to log in with the wrong credentials, and the login failed. And I can try to log in with the right credentials, and it should pass. And I have a secret page there, which is particularly exciting. What else do I have? I have the asynchronous version, right? I mean, today's web applications are all about asynchronous. So I have the asynchronous login, which can be a testing challenge. So now I get this amazing animation. I think this was the best I ever did. And then it automatically, after a while, it transitions to the login successful, or we have the same again for the failing login. So login failed. So that's a little bit more challenging to test. And then to show off some more advanced interactions with the browser, I have a drag and drop. And now the question is, how can I script the drag and drop, or can I do that? Can I write a test that drags and drops things around? Okay, so let's have a look at how we could do that. Okay, so first I'm going to show you the low-tech solution, and then I'm going to show you the really nice one. So this is the most straightforward way. You just put, CHEP has a special Spock adapter, so you put the CHEP Spock char on your test class path. So I have a Gradle build here where I set all of these things up. So here I use some CHEP Spock here, and I use Spock core here. And I have some report configuration that I'm going to show you later. And now let's focus on the spec. So this is a straightforward way. You extend CHEP spec or CHEP reporting spec. With CHEP reporting spec, you also it captures screenshots for you, which can be really helpful if the test fails. You can look at the screenshot. It also scrapes the HTML pages. So it gives you more reporting convenience. And then we want to test a workflow, a small workflow. First of all, we want to log in, and that should succeed. And then, if you remember, only after the successful login, we were able to navigate to that secret page. So that's the two-step workflow that we want to test here. And that's something that you will often have in a real world. In a web application, you want to test a workflow. You rarely want to test just one page, one thing on a page. You want to do, put things in the shopping cart, then check out, make payment, this kind of workflow in multiple steps. And here comes a handy Spock annotation, which is add stepwise. It works also outside CHEP for any kind of test. And what this means is that if you annotate your class with add stepwise, then Spock understands that each method is a step in a workflow. So without that annotation, Spock will assume that each test method is independent. With this annotation, it will guarantee that all of them run sequentially, and it will also stop as soon as the first one failed. Because if I cannot log in successfully, probably doesn't make sense that I try to navigate to the secret page. That will just give me more reds which don't have a meaning. So in this case, it's actually good to stop once the first one fails. Okay, so how do we drive our browser? And here is the direct way. We directly drive the browser and directly access the HTML page. That's not the most sophisticated way, but it's a good way to get started. So one of the methods that we get with this CHEP spec is a Go method that allows us to navigate in the browser to a page. So we go to the login page. This is relative to a base URL that I set up in my CHEP config. Here specified the base URL, and so I'm going to the login page relative to that. Okay, so I'm using a real browser here. In this particular example, I'm using Chrome. So when executing this code, CHEP will take Chrome to the login page of my app. And then comes my expectation in the then block. That's again a Boolean expression. And here, CHEP offers a jQuery-like API. So you have this $ function provided by CHEP, which allows you to select any content on the page. So here we select our heading and read the text of that, and we expect that the text equals please sign in. So everyone who feels comfortable with jQuery can immediately write this style of tests. Again, a state-based test that drives the browser, navigates somewhere, clicks a button, fills in the form field, and then makes some assertions against the HTML of the page. So given that the application is running, let's give it a try. You should be able to run it from the IDE. Yeah, looks good. Takes a little bit longer. You saw the real Chrome pop up for a second. Okay, worked. It's the usual game with Spock. You make the assertion fail, and you'll get the usual output. So getting started is really, really simple. So you get the usual output, and you get the diff. Yeah, I'll show it in a minute. So I will show it. Okay, you can add multiple when-thens. After first you check that the right message occurs, and then when you make another interaction, now we are not navigating, but we're filling in form fields. And filling in form fields with CHEP is as easy as assigning to variables. So these are our form fields named username and password, and I just pretend they are variables in there and assign it. And CHEP will make sure that the form gets filled in the browser. So we assign the username and the password, and then we click this sign in button. So we submit the form. And after we submitted the form, we expect the heading to change to login successful. So that's how easy it is to get started with CHEP's language and Spock. You see also that I annotated all the individual steps here. That will come in handy later when I generate the reports. So for unit tests, typically I don't add explanations to each and every block. I just concentrate on having really expressive method names. But for higher level tests, acceptance tests, it can make sense to document each step. And as we'll see later, you'll get this output also in your reporting. Here we have another one. This comes after the successful login. You see here the login failed, and it didn't even try to run the second one to prevent this false positive. Why try to navigate to the secret page if the login failed? Here's another one. So here we select the button, again with the $ function, and then we have this click method. That's how easy it is to click a button. And then again, we check against the state of the page. So really easy to get started. But if you use it for acceptance testing, as the complexity of your application grows and your test suite grows, there's one big problem with this style of testing. And that problem is that you're directly interacting with the page. So you're assuming a certain structure of your web page in your test. Now imagine you change the HTML a little bit. And probably you might have a lot of tests that pass the same page, that need to go through the login or something. And now whenever you change something in your HTML, you potentially have hundreds of failing tests, and you need to find all the places where you need to patch up your tests. So this can easily and quickly become maintenance hell. And this is where one pattern comes in which CHEP supports natively, which is the page object pattern. And for those of you who have used Selenium, also Selenium has first-class support for the page object pattern. And the idea is that you put a small little abstraction between your test and your HTML, your web page. A small little abstraction that abstracts the page for the purpose of the test. So instead of filling in the form field and clicking a particular button, I want here to say just login. I want to call a login method and then pass the credentials. And then what that means in terms of the interaction with the browser, that should be captured in that login method. So then whenever anything changes on my login page, I only need to fix that one login method and not all of my tests. That's the idea. And page object is because you put an object that models the page just as good as it's needed for your test, and you put that between your test and the browser. That's why it's called page object pattern. And here we have one example. Now we're testing the same login screen, but we're writing this page class, and JEP has first class support for that, so you extend the page class. And I'm not going to dive into all the details. JEP has very excellent documentation and excellent manual, and there are lots of talks out there on the web, so please look it up if you're interested. But to give you a quick idea, a page has at least 3 components, and for those of you who are coming from Grails, this will look more natural. It's a Grails-inspired DSL. So you need to tell a page 3 things. What is URL relative to the base URL of the application? So it's the login page. Then you need to give it a Boolean expression so that it can test whether it's really the real page. So for example, when you tell it to navigate to that page, it wants to make sure that it really ended up on the right page in the browser. So here, our check is if the title of the HTML page equals sign in page, then yes, we are on the login page. If not, we are not on the login page. And the third thing is you provide this little abstraction. And again, don't worry, this is just a DSL. That's just JEP's DSL to give you a little abstraction. What it does is it binds a name, like this is the form, to a jQuery expression. Right? So that in the test you can use this name, and it will actually do this. And so whenever your HTML changes, you keep that the same and just change your expression here. That's the idea. Again, if you want to access the heading now in your test, you no longer hard code H1 in your test, you just say heading. And JEP will translate that to the H1 element, and it will get the text of that. If you click the sign in button, you use that variable in your JEP test, and it will look it up this way. If the name of that changes, you just change it in here. And of course, you can go, like, you can have more complex expressions here. You can pretty much everything that you can feed into jQuery, you can also feed in here. It's not the jQuery API, but it's heavily inspired, and it's very powerful, and it supports CSS3 for the browsers that support it, and you get the CSS engine of the browser. So if the browser has a fast CSS engine, your tests will all be a lot faster. So a lot of things you can do here. And then you can also add to that little abstraction, you can add additional methods. So if your tests often need to log in, you just add a login method. That's what your tests are going to use. And the tests are going to pass the username, the password, and the checkbox, whether to remember the value. And then this method, again, translates this to filling in the form fields and clicking this particular button. Again, if anything changes about your form field, only this changes, and all the clients remain the same. So it's a really easy pattern, but it's very, very, very useful. And you absolutely need it if you want to really functionally test your web application. Otherwise, things will get out of hand. Okay, now let's look at the spec that makes use of the page object. So here, it also cleans up your test and makes it really more readable. So now you no longer go to a particular URL, but you say just you go to the login page. And what URL that maps to, it's now encapsulated in that page object. So it's a really simple idea. Again, now we access the heading. The fact that this is the H1 is again captured in the login page. We can check the 2 form controls, and here we are using the login method. So all our tests use the same method, and what exactly login means is now captured in here. You see here the JEP DSL is pretty dynamic. So where does this login method come from? Why don't I have to write something like, I don't know, browser.page. something like this, right? This would be like something you would expect from Selenium. But JEP really takes a lot of boilerplate out of it, and it will automatically, if you just say login, it will search for that login method on the current page, so that you don't have to write things like browser.page, browser.page, browser.page. The one disadvantage is that in this case, IntelliJ cannot complete it. So IntelliJ doesn't know where this comes from. But IntelliJ to the rescue. If you just use a little bit more typing, now again, we go to the login page, but we save that page off in an object and then just say page.page. That's still quite readable and nice. And now IntelliJ can complete it. And it can even complete these guys here, the heading. You should be able to do that as well. So let me see. Let's go back. Page.heading, and it navigates here. And that's really, really cool because it means that IntelliJ understands the CHEP DSL. So IntelliJ ships with some CHEP smarts. By the way, it also ships with some Spock smarts. But that really helps. So it's still very readable. Only thing you need to add is this page dot, and now you get full navigation, refactoring, and everything you could dream of. OK, let's move on. Let's go asynchronous. Now it gets more interesting. You remember this asynchronous page that inserts some HTML dynamically, that red bar for the wrong login, and that's a challenge for testing because now it's no longer request response. With static web page is very easy. You send the request, you get the full response, and then you pass the HTML. But now you have to somehow wait for events to happen. How can you do that? Again, we captured all the details and nitty-gritty details in our page object. Here we go. It's again similar. So we introduce a few abstractions here. And one of the standard ways to deal with dynamic content is you wait for it to appear or disappear. So we wait for this alert box to appear. And the way to do this is, for example, we wait for the alert dialog. So the alert dialog maps to this jQuery-like selector. But this will not be there initially, right? Only sometime after we enter the wrong credentials will this be inserted into the DOM. And in many cases, it's really, really simple. You just have to tell CHEP, this is dynamic content, and tell it to wait. And what it will do then, it will wait for a couple of seconds and will poll this expression. It will check again and again and again whether it appears. And either it appears or a timeout occurs. And of course, the timeout is configurable. So I think by default, it's something like 5 seconds, but it's very configurable, like how often should it poll, how long should it wait. You can configure it in the configuration file or even in your test class, so it's very configurable. So in general, that's the way you do it. You wait for some content to appear or some content to disappear. So here it's the opposite. So we want to check that the alert dialog is closed. So we wait for that diff to disappear. So you see not displayed. Every element has a displayed attribute, and so we wait until that's false. And again, you can use here the same expression language as Spock, any Boolean expression, and it's another kind of assertion. And again, you don't need to write assert here. Both Spock and CHEP can take care. So that's boilerplate, so let's not write it. Okay, so that's a basic idea how you deal with dynamic web pages. I have one more, which is the drag and drop. You remember the drag and drop, and now we want to drive the browser and make the browser drag and drop. And again, the nitty-gritty details are in the drag page. We encapsulated that. And again, what I didn't talk about before, you can subdivide a page further into components, as you would in a component-oriented web framework. If you have reusable test abstractions, like you have that login form that appears on many pages, you cannot only create an abstraction for your page, but also for a component on your page. And that's called a module in CHEP, and works very similar to a page. You just have to tell it then this page has multiple modules, and this is our abstraction for the module. And in general, it works very similar to a page. Here's some computation. We want to drag it with some horizontal and vertical offset. And there's really just one thing that's interesting in here. This just computes some coordinates, not interesting. And now how do you make the browser really drag it? That's the interesting part. And here, Selenium provides, or WebDriver provides an API out of the box for advanced interactions with the browser. And CHEP just integrates with that. So you have the full WebDriver API if you need more advanced, if you need to do some special key presses, up, down, or drag, then you can use that API. And here you can just say drag and drop by some relative coordinates, and that's it. And let's have a look at what our spec is doing here. Should be the drag drop spec. So it's really just dragging things around. It's not really checking anything. It's just, first it has a blue square and it places the blue square at these coordinates, and then it tries to circle the green one around the blue one. And you see the then here is a little bit cheap because we are actually not asserting anything. We are just showing you how you can do advanced interactions with the browser. Okay, let's give this a try. Of course, I could run all of these tests from the command line as well, from my Gradle build, would work exactly the same way. And that was a little bit too fast. So maybe let's run the whole thing from the command line. So far, all the demos have been too smoothly, except for the keyboard. So let's step it up and let's just run a Gradle test, I believe. That should run all the tests we've seen. And we should also see the browser interaction. Yeah, it's trying to check whether there's a new snapshot on the internet. It's not a good idea here. Let's give it a second or two, otherwise let's run it offline. Should also work offline. Let's see if that helps. Yeah, it looks better. It's already running the tests. And we should see a browser at some point. Here we have some sign-in, and then that's the static version. And then now that's the dynamic version. And now it's the dragging. And you see we played a little game here just to show off that you can do some advanced browser interactions. Okay, so that's a general high-level thing. Of course, you need to look a little bit closer if you want to write your own tests, but you see the language is very clear, very little boilerplate. And if you start with a simple form field, you can get started really quickly. Also, navigating between your pages is really easy. You can just say this button on this page, on my page abstraction, takes me to that other page, and then you can directly click that abstraction and it will take you to the other page. So it gives a really nice language to automate your acceptance tests. Now, one more thing I want to show is the reporting we are working on. Okay, so let me see. This is which one? The demos, you mean? Yeah, I'll make them available.
Can you show us the zip config to report?
Yes, we should. Yeah, we'll have time for that. Just a second. I want to show the report first, and I think I should run it again, but with a clean, because the whole report is still there. Now pray, because this is very much in the works. Oh, I forgot the offline again. Let's do the offline. And now we should get a report and get some additional diagnostics. Okay, currently nothing is breaking, but nevertheless we should get a decent report that tells us the outcome of the test. Okay, so it's already running. One more time. Okay, and here I'm showing off the Gradle integration. We're also working on a Maven integration, but here, after the tests have run, it shows you where it put the report and whether it failed or not. On Mac, you can just command double-click it. That will open it in the browser. And that's the kind of report we are working on. So we are trying to remove the technicalities like class, method, and to make it more read like a requirement specification. So here, we can show all of them, or just the passed one, or just the failed one. We don't have any failed or skipped ones, so only passed one in this case. We can search for just the ones that have navigate in the name. We're also working on making it dynamic so that this gets populated while your CI server or whoever runs the tests gets dynamically populated. What else do we have? We can show the full details of everything. That's also interesting. You remember the labels, the when and thens that were annotated with a string. They show up here. So it hopefully reads like a requirement when navigating to the login page. Then a please sign message appears. When the correct credentials are entered, then the login succeeds. And it relates it to the method. What else do we have? Oh yeah, it shows you the attachments. So you use it by default. It will take a screenshot at the end of each test. You can also manually take a screenshot from the test wherever you want. But default, you get one per test, and you can open that. And it doesn't look very great by now. This was not the best one. It doesn't look so great yet, but it already shows the concept that you have all the screenshots easily available from this report.
Do you have use like both Spock and JUnit kind of together for this one to report the Spock tests?
So this one is currently Spock only. We could make it work for JUnit to some extent, but you wouldn't get all this when then. So currently this report is Spock only, but all your other reports, your JUnit reports, if you have a mixed JUnit Spock code base and you create with Gradle or Maven a JUnit report, then you'll have Spock and JUnit in the same report, right? Yeah. Like on Jenkins, wouldn't make a difference. One report for both of them, because to an external tool, it just looks like JUnit. So it's seamless. But this one is something we implemented, and currently we only implement it for spec. You can go further and also give the test classes a nicer name. Because for the test classes, you can't use a string in Groovy like you can for the method names. But there are a few tricks you can pull. Like there is a new add title annotation. And if you give it there, this is my drag and drop, then this is what you see in the report instead of the technical class name. There are a few more things. You can add a narrative. If you're into BDD, then you can, with a multi-line string, and then you can say as a user, you can put your story there if you want to. You can link to issue tracker, so you can say add issue, and then link to your issue tracker if this is a regression test for an issue, and then this link will show up in the report. So there are a few interesting things how you can spice up the report so that it's interesting potentially for other stakeholders, not just for developers. That's one of the ideas. Probably, your boss is not going to write this code. It's maybe if he's really deep into tech, he will kind of try to read that a little bit. I don't think he will write it, but at least he should get a decent report that makes sense from more of a business perspective. That's our goal. Mm-hmm. There is a way already to configure the report with a base URL, and then you just put in the rest, yes.
Is there a way to tell which browser you want?
Yeah, so that's a CHAP thing, and so CHAP configures WebDriver, so I didn't go into that, but we can have a quick look at how we set up CHAP. So there's this CHAP config file here, and here I told it I want Chrome. Also supports Firefox, Safari, Internet Explorer. You can also test Android and iOS. So WebDriver does all the heavy lifting here, and it's one of the best browser automation tools that's around. And also you can also do it right in your JVM with HTML unit, but that's not meaningful for testing, But it might be a good if you use CHAP for scraping a web page. That's another valid use case. Then the HTML unit might come in handy. But if you use it for acceptance testing, which is kind of the primary use case, then you would always use a real browser. So there are lots of things actually you can configure here. There's also a cloud service, Source Labs. So if you don't want to, set up all the different browsers on your machines, especially on CI, that gets involved, and takes quite some resources, and then you need to fan out. So you need to have the server who finds the right browser on your Windows machine. So this can get complicated, and there are cloud services that offering that service to you, and they integrate right with WebDriver and therefore with CHAP. So if you prefer, send them some money, and then they'll take care of it. So that if you have heavy requirements in terms of testing against many different browsers of many different versions of many different browsers, then it's likely a good investment. It's something I would look into. Get a trial account and look it up in the JEP docs, and that will refer you to the WebDriver docs, and you can have this running in an hour or half an hour. If you try to set it up yourself, it's more involved. I've done it before, and then you have to set up a headless X server or something on your Linux CI server so that it can run the browser, so that's more involved.
I just had a question about what your opinion is on, like I had to do with Spock where the main problem that I run into with Spock and Jet is that if I'm not doing stepwise tests and I have a big like testing application that's doing a browser test, and I've got some very data over here in my test, and I'd like want to do another test that like I want to remove that data, and I don't want that data to show up. So I basically like test isolation as far as the browser testing goes. And I'm wondering if there are any strategies that you know of to sort of like help alleviate that.
Yeah, let me think about it. In general, if you need a lot of data in your app to begin with to test it, then you typically don't want to insert the data through the browser, right? Because it's very slow, very painful. So if you need a base set of data available, then you would provide another entry point, so that, for example, your build before it fires up the JEP test can already seed the application, right? Via some admin, REST API or whatever. Other than that, let me think. So in the database world, that in Spring it would be easy, would be transactions. Right. The Spring Test Context Framework, you just roll back what you did. So you seed the database with the base state, and then you run your code and just roll back at the end of the test. Is that something similar what you're looking for? Yeah.
Something like that. I'm wondering what strategies are out there that are some ways to do that with.
Yeah, so in any case, you need, so in this example, I fired up the web app myself manually, but if you have this automated suite, you will have to automate that as well, right? And that you will typically probably do in your build tool, because you have more leverage there. And of course, in the build tool, you have full control. You can fire up multiple instances with different data sets, and then throw some data here and throw some data there. In general, only test like deltas. Don't make absolute assertions what's in there. Only make assertions on what you added or what you removed. And of course, you need some kind of isolation so that not multiple tests are hitting the same instance, because then you might make wrong assertions. But make it as in database. Don't make too many absolute things. Try to keep your assertion semantic. So say I think I added 2 things, not 576 things must be there. That would be one idea that springs to my mind. Okay, we have a little bit of time. Do we have more questions? Yes.
You said that JET runs over Selenium. Okay, so the Selenium, is it making calls to the Selenium API and the cover, so you need to have all that on the class path?
Yeah, you need to have it on the class path. It's not so bad. Let me see if I can find it here. Where does it actually come? Oh, here's the driver char. I'm not sure, it might have some third-party dependencies, but all I declare here is one driver char, and there should be one for each driver. So I've scripted my build a little bit, and I said here drivers I want to test against Chrome and Firefox, and then for each of them I set up the corresponding Selenium dependency, and that was it. So. Depending on the browser, you have to install some more stuff. So for Chrome and IE, you have to install the shim. So I had to install a Chrome driver executable on my Mac to run it. As far as I remember, you don't need that for Firefox, if I'm not mistaken. So, but as I said, this setup. On the other hand, driving Chrome is really fast. That's the advantage. So it's really, really fast, but it needs a little bit more installation. And if you're not so much interested in that, then consider outsourcing it if that's an option for you. It's certainly an interesting option.
So, and I apologize if this is more of a JEP question.
No problem.
So you're using Spock with JEP to test the web page, which
Mm-hmm.
returned HTML.
Mm-hmm.
But what if I wanted to test like my REST APIs? Would you still use JEP? Will it work with XML the same way?
Yeah, so generally I would use it for HTML. There are other libraries for lowercase REST testing. Good question. Well, yeah, you can go low key and do it all in Groovy. Interacting with a basic REST service in Groovy is really easy, and parsing JSON and parsing XML is extremely easy in Groovy. So yeah, you XML slurper, JSON slurper, these kind of things. That would be one option. But I think there are also some JUnit-based tools, and I don't remember the names, but there are some tools out there, and they will also work with Spock. I mean, what was the name of them? I've just yeah, Rest Assured is one of them. Yeah, yeah. Okay. I haven't used it, but okay. Do you have any more questions?
So do you recommend to have all these functions inside your project, your application, or outside?
Good question. I mean, it depends on how large your project is. Yeah, in general, if it gets larger, perhaps outside, because it would also be really nice if you can run this against your production app, just as a smoke test. After you release a new version and you're not routing anyone there yet, just run this as a smoke test suite. Why not? I mean, it can't harm it more than a user. So then I would tend towards either a separate sub-project, but if you want to run it really independently, I think it's fine to make it its separate project. And you have your own abstractions, right? The page objects and so on, and so you don't depend on any APIs. So separate would be fine.
When you put out a release, an update to Spock, how long is it before JED is updated to be able to use that release?
That's a good question. It doesn't necessarily have to be updated, so not always. I think for this release, it will not be necessary to update it, but in general, it's like so the two main guys behind JEP, it's Luke and Marcin, the new lead. They are both co-workers of mine. So it's basically when I send them a message on HipChat. So very fast in general. They're very fast. They are much faster, coming after Spock than I'm releasing Spock. So should be fine. Okay, last question.
Yeah. I just want to say thank you for having me.
Oh, you're welcome. Anything else? That's not yet, but I'll upload it later today. So that's everything I wanted to show. If you want to hear more, I'm at the Grailware booth until the end of the conference, or if you want to talk Gradle, continuous delivery, or Spock, then come visit me. Thanks a lot and have a great conference.